Next problem. Let g be a polynomial function. G is equal to this. 2x squared minus 3x minus 2. And then it says x minus 1 is a factor. And it says to write this as a product of linear factors. If we remember, linear factors means things like this. All right? We got to have x's. We can't have x squared. We can't have x to the third. Just x's. And they got to be multiplied. So this is where polynomial division comes in. We write g right here under the doghouse. 3x to the third plus 2x squared minus 3x minus 2. Then we divide by x minus 1 because they already told us this is going to fit really well. Great, so let's do it. We go, what is x here? What do we multiply x by to get 3x to the third? That's going to be 3 to get that 3. And then x squared to get x to 3x to the third. Or to get it to the x to the third part. So we then multiply 3x squared times x. We write that answer here. Because this is a polynomial, that should be 3x to the third. Because this is a polynomial, we also have to multiply by this negative 1 right here. So we do that. And that gives us negative 3x squared. And we subtract. When we subtract, we switch the signs of both of them. Because you got to carry that over. You got to make sure you're not just subtracting half of this number. That wouldn't make any sense. 3x to the third minus 3x to the third is 0. It's the same thing. 2x squared plus 3x squared is 5x squared. Same exponent, so we just add the number. Then we bring this on down. And we do it over again. All right, we say x. What do we multiply x by to get 5x squared? Well, that would be 5x. We multiply 5x squared. 5x now times the negative 1. This becomes negative 5x. We subtract, change both the signs. 5x squared minus 5x squared. Why, that is a good old 0. Negative 3x plus 5x. That's positive 2x. Bring this on down. Almost done. Now, what do we multiply 2 by to get 2x? Why, that would just be 2. So we write plus 2. And we go 2x. 2 times negative 1 now is negative 2. Subtract them both. This leaves us with a big old 0 for everything. And we can write that the original g of x that we had can now be written as x minus 1 times, this is 3x to the third plus 2x squared minus 3x, minus 2. Is it minus 2 plus 2? Yep. All right, so we got, it's plus 2 in that one. Wait, I was copying in the wrong number. All right, ignore your insane math teacher for a second. 3x squared plus 5x plus 2. That's what we need. Now, is this in terms of its linear factors? That's what we need for the problem. Don't stop halfway there. No, it's not, because we got an x squared here, so that's a bad sign. So, we have to factor a quadratic. Factor a quadratic. I know it's scary words. Don't you worry, though. Don't you worry, though. First thing I recommend, there's a number here, divide each thing by that number. All right, this is called factoring out. So the 3 goes here. We say, hey, I'll multiply it later. And then we're left here with x squared plus 5 over 3x plus 2 over 3. Now, when we see a quadratic, we can write it like this. And then 2 numbers that go here and here, when they multiply, so something times something, I should use a dot for multiplication, equals 2 over 3. And then something plus something equals 5 over 3. All right, now This might send you, make you a little bit shy. You might go, oh, I don't really understand. How do I do this? Well, factors are a bit rough. I'll give you that when it's for fractions. But I want to remind you, I didn't write this test. All right, where I'd go, 2 over 3. There aren't super many easy things to add to get that. But you can add 2 over 3 times 1. However, if I want this to be a fraction, if I take that and I go 2 over 3 plus 1, how do I add that? I can't just add that straight. I've got to rewrite 1 to have the same denominator as 2 over 3. So I'm going to rewrite that as 3 over 3, right? Because anything divided by itself is 1. I add the top numbers, and that gets me this. So we factor it. We have now figured that out. And we go... is this minus? Plus 2 over 3 plus 1. And then we bring down these parts because, they're still a part of it. And we have just written G in terms of its linear factors.